Kinetic theory. Let's start off by looking at atoms and the properties of matter. The idea that all familiar matter is made up of atoms goes way back to the ancient Greeks, to Democritus in 460 to 370 BC. He proposed that if one was to cut a piece of iron into smaller and smaller proportions, there would be a portion which could not be divided further. This smallest piece he called an atom, meaning indivisible. Another of the scientists who was working with gases, John Dalton, reprised the theory of atoms. His experiments led him to propose the foundational postulates of modern chemistry, and the first of these was that elements, which are the fundamental materials, are made of atoms, and that all atoms of a given element have the same physical properties, such as mass or size. From Dalton's principles, it followed that properties of materials are determined by the properties of the atoms in the material, the motion of those atoms or molecules, and their interactions. In fact, the properties of matter we've studied so far, thermal expansion, melting, boiling, cooling, heating, can be explained based on the concept that matter is made up of atoms. Kinetic theory is the first of the theories of materials. It relates the motion of the atoms or molecules, which comprise a gas, to the thermodynamic properties of the gas. Kinetic theory provides us with a better understanding of temperature, heat, internal energy, and even pressure. So let's look a little bit more into kinetic theory of ideal gases. Now, the study of a real gas can be mathematically complicated. We have to consider a lot of different things. First of all, we have to consider the motion of the molecules in the gas. And we have to consider the motion of the atoms inside each molecule. We need to know whether the molecules will repel or attract or even stick together. And we have to even know if they're going to combine chemically to form new molecules. So in our application of kinetic theory, we'll be using a set of simplifying assumptions called the ideal gas model. Here are the assumptions of the ideal gas model. Number one, the gas consists of a very large number of particles, that is, atoms or molecules, all confined to a container. And the walls of that container are rigid and very massive. The third assumption is that the particles behave as point particles. Their size is small in comparison to the average distance between particles and to the size of the container. And finally, the particles are in constant motion. They obey Newton's laws of motion. And each time a particle collides with the wall of a container, the collision is perfectly elastic. That's because the walls of the container are rigid and massive. That means that no kinetic energy is lost on a collision and that the speed of the molecule remains unchanged.